This is Team 25, and we are dealing with a project with training a neural network inside of a UI that will help identify distracted drivers. The first thing we'll show is our UI itself. The UI is this. So right now there is a select data field. When clicked on, it will pop up another field that will allow you to select files, and when you select like the readme file and hit open, right now it shows in the console log that the file has been selected and what the full path name is, as in blue right there. And then when the user would click graph data, it should graph the data that was selected. Right now that's not implemented, but the all thing coding wise is done. The plot data will plot the accuracy of the neural network as time goes on, and that will be shown after or during the neural network being run. When they hit run, it will run the preprocessed file that was selected from the data. So they'll select the data, and then that will be preprocessed, and then we run it. And then from there, if they hit edit neural network and they don't like the accuracy, they can edit the hyperparameters of the neural network and then update that. So it updates the neural network code. That way, if they run it again, it'll have a different run case and accuracy because of that. And that is our pretty much neural. Also, there's the load save neural network that if you save it, you can use the base neural network or have a loaded model that's been saved before. Next, we're going to go over our graphs for data.
Okay, so this is graphing data 2 using a type of scatter plot. Say that this one might be the best representative of acceleration versus velocity. Of the other ones were just the other various variables, speed limit, velocity versus response time or mistakes.
So that shows our data, how we're going to graph it for most data cases. Right now we're just showing one data case, but this is being graphed the same kind of way for all datas.
Yeah, as I said, this might be actually like the best represented way to graph our data.
Next, we're going to show our neural network running. So right here, we're just going to run it pretty much. So right now, the first block is importing just the stuff that we need to run our code. So right there, we're loading our data from 3 NPZ files. That is the test, train, and validation sets. And then this is our model. Right here identifies that there's 7 inputs and 3 outputs, and the outputs will help identify the accuracy. We have a sequential model, and right now there's only 2 hidden layers. Our optimizer is just right here. It shows us the accuracy once we have everything trained. It's taken a little bit of time to run though. That is our training. It's a total number of epochs of 10 with a batch size of 5. And right there is showing our loss, accuracy, and stuff like that. So it goes from low accuracy and it gets a bit higher. And there is a early stopping thing. So if the thing increases and then starts going down in accuracy by 2 runs, it'll stop on the 3rd one if it's going down. That way we don't overfit or underfit too much. And then we have a test, and it's running our test data. And the accuracy of our test data right now is 41.51%. As just said above, it grabbed the 3 NPZ files, so all data files will give a train, validation, and test NPZ file. And this shows how that was done. So this is for data 1, where it takes one cleaned file. It grabs certain values, so we're only taking in 7 input and 3 output, which is described in these values right here for velocity, lane, position. That's our input. And then right here, it's kind of pre-processing, taking out anything that is zeros or dashes that shouldn't be in there. This data set's chunked up weird, so it has to take in certain accountability for multiple rows or certain single value rows. And then this is our output. This is taking out everything that we don't want in there and only leaving the 3 columns that we do need. This is scaling and shuffling the data so that way it can be ran multiple times with the same data set and not overfit the model. And this is where it splits into train, test, and validation, and then it saves the train, test, and validation. Right now, the limitations of this is our UI is sort of halfway implemented. Right now, it's not running the files that have been made, but the files do run and do work. It's just it's not connected to the UI. I think right now we're going to show you our code base for GitHub.
Okay, so first we have our data files. This is where all of the data is going to be clean. Each data set was different, but they were cleaned relatively the same way, and they all pop out output that's used to be put into the pre-processing used for the neural network. These are all for data 1 and data 2 and data 3. Okay. And the next is our neural network. Now this says data 1 neural network. This will be applicable to all data sets. And it's what we just showed, so it's the pre-processing as well as the neural network files. And the last one is for the UI, and it's just a single Python file that displays our UI. So as for our code base, the sponsor did not provide any initial source code, so everything we did was based on our own and using libraries such as Matplotlib, NumPy, TensorFlow, Keras, Pandas. Those are the only additional libraries that we use that weren't our own.
Now we're going to go over our Google Drive that displays all our other content. So right now there's a bunch of folders set up. As you can see below, there's our team contract that involves certain risks for not contributing or not showing up to certain things, and an Excel file called strikes that shows who didn't follow this contract. And then there's a bunch of other folders involving multiple categories. And so sprint 2, 3, and 4, we started that because it was requested. So sprint 0 and 1 is not included. The sprint 2, 3, and 4 just is our deliverable files, so everything that we did during that we needed to turn in. Our data log folder shows each person's contribution to a certain task or deliverable that could not be done or shown in GitHub. And it's a timestamp to verify that we did our work when we did it.
We also have all of our diagrams, UML and such for the UI and the neural network, as well as all of our meeting minutes and questions for our sponsor meetings that we store them all here for processing and then so we can send them off, as well as other ones for our project plan and other files which didn't fit any specific category.
Right now our project is on track in most scenarios. We did not achieve a high accuracy for all neural networks, so that's kind of where we're off track. We're exceeding expectations because we were not supposed to have a UI involved yet, but we have a UI almost set up and almost fully implemented, so that's where we're exceeding expectations. But we're not exceeding expectations when it comes to the neural network and the accuracy that's been achieved so far.